Hi, Patrick. Let's start by drawing what that molecule would look like. 2-ethyl 3,4-dimethyl octanal. Oct means 8 carbons, so there will be a parent chain with 8 carbons. 1, 2, 3, 4, 5, 6, 7, 8. Al ending on octanal means aldehyde, which is always going to be on the end of a carbon chain. And then there's going to be a 2-ethyl, so counting here, 1, 2, 2-ethyl, and 3,4-dimethyl. So here's 3 will have a methyl, and 4 will have the other methyl. So 3,4-dimethyl. Now, a reduction in organic chemistry is usually going to involve taking away bonds to electronegative atoms. The only electronegative atom here is oxygen. Now, in general chemistry, reduction has a more general meaning, as in to add more electrons. But in organic chemistry, it's usually, almost always, going to be adding hydrogens on either side of a double bond. And right here, we have a double bond, or a triple bond would also be an option. So if we're going to reduce this aldehyde, we would make 1, 2, 3, 4, 5, 6, 7, 8, and an alcohol instead of the aldehyde. Now here's the hydrogen that was there before, and here is the new hydrogen that got added. So see how we added an H to one side of this double bond here, and we added H to the other side of the double bond here. Okay, so the other groups are unaffected because they are not involved in this reduction. So those methyls and the ethyl are still there. Now, if we're going to name this, we're going to start with the longest carbon chain that contains the highest priority group, which is this alcohol. So here, 1, 2, 3, 4, 5, 6, 7, 8. So it's still octanol, but this time it's going to be OL because it's an alcohol and not AL because that's for aldehydes. So we'll start with octane as the parent, but in this case, the alcohol has to be specified where it is. Notice that in the name for the aldehyde, they didn't tell you where the aldehyde was, but they didn't need to because the aldehyde is always on the end that will count as 1. Here, an alcohol could be anywhere in this molecule. So we have to specify that it's going to be at carbon 1 of the 8 carbon chain. So 1 all. And the other groups will be the same. Since counting didn't change, it's still here as 1. The other groups will also be at 2, 3, and 4. So 2-ethyl, 3,4-dimethyl, octane 1 all. Hope that's helpful.